Hello children, now let us start with the chapter Electrolysis. This chapter deals with a process called as electrolysis, which establishes a relationship between electrical energy and chemical change. The word electrolysis is made up of two words, electro, which means flow of electrons, and lysis, which means separating. So bringing about a chemical change in a substance by passage of electricity is called as electrolysis. Many substances allow electricity to pass through them and many do not. It has also been found that all substances allowing passage of electricity do not undergo chemical change. Most metallic elements like copper, aluminium, and alloys are known to be good conductors of electricity, and non-metals like sulfur and phosphorus are known to be poor conductors or bad conductors of electricity, except for non-metals like graphites. Graphite, being a non-metal, is a conductor of electricity. We have to keep this in mind, that graphite and carbon are good conductors of electricity. Now let us see the next topic, that is electrolyte. To know electrolysis, first we will start with one topic, that is electrolyte. So what's an electrolyte? What are electrolytes? Electrolytes, they are compounds which are either in aqueous solution or in molten state. They allow electricity to pass through them. So any compound which can allow electricity to pass through it. So it has to be in an aqueous solution state or in a molten state. So it has to be an aqueous solution or a molten state. Only then electricity will pass through it. Please note, it does not allow electricity to pass in solid states. So these compounds do not pass electricity or do not conduct electricity if they are in solid state. Let's see examples of electrolytes. So they are molten salts, solutions of salts in water, or solutions of acids and alkalis. So which are the examples of electrolytes? They could be salts, acids, or alkalis, but in their molten or in their solution state, in their aqueous state. Sodium chloride, hydrochloric acid, and sodium hydroxide. These are some examples of electrolytes. Now, what are acid electrolytes? Naturally, by the term acid electrolyte, when we are talking about acid electrolyte, it means the acids which behave as electrolytes. So, the examples are hydrochloric acid, HCl, sulfuric acid, H2SO4, and acetic acid, CH3COOH. So, here we will note that hydrochloric acid and sulfuric acid, they are strong acids. These are strong acids. And acetic acid, it is a weak acid. So strong acids also act as electrolytes and weak acid also act as electrolytes. The only thing is, strong acids will act as a strong electrolyte, whereas a weak acid will act as a weak electrolyte. And why it will be so? Because strong acids will be able to conduct more electricity. Strong acids will be able to conduct more electricity than weak acid. Weak acid will not be able to conduct so much of electricity. That's why it will be a weak electrolyte. We will see that in the next topic. Before that, let's see basic electrolytes. What are basic electrolytes? So the bases that behave as electrolytes are basic electrolytes. So sodium hydroxide, potassium hydroxide, or ammonium hydroxide. So in this also we have the first two examples here. These are strong bases. Whereas the next one, ammonium hydroxide, it's a weak base. It's not a strong base. Now let's see the next topic, that is salt electrolytes. Now these are the electrolytes which are basically salts in their aqueous state or in their molten state. So salt electrolytes. So example, sodium chloride, potassium chloride, or copper sulfate. Many other salts could be a nickel sulfate, silver, argento, cyanide, etc. So whichever salt is used as an electrolyte which is capable of ionizing is called as a salt electrolyte. Let's go to the next topic, strong electrolytes. As we have seen in the previous example, what are strong electrolytes? These are electrolytes that will be able to ionize fully or completely. Let's see the definition. A substance which ionizes completely when dissolved in water is called a strong electrolyte. So it contains only ions in its solution. So strong electrolytes are those electrolytes which contain only ions in its solution. Why? Because once it is dissolved in water, it completely ionizes. What is the meaning of ionizes? It completely separates. So suppose you are talking about sodium chloride. So sodium will completely convert into sodium ions and chlorine ions. And that's why it's called a strong electrolyte. Then its ability to conduct electricity is high. So it has a very high ability to conduct electricity. So that's why it's called as a strong electrolyte. Now let's go to the next topic. That is weak electrolytes. Naturally, what are weak electrolytes? Now we can say that substances which ionize partially when dissolved in water, they are called as weak electrolytes. It contains both ions and molecules in its solution. Now since they do not undergo total ionization, since they undergo only partial ionization, hence because of that they are definitely going to contain both ions as well as molecules in its solutions. Its ability to conduct electricity is low. So in this case the ability to conduct electricity is low. So weak electrolytes will conduct less electricity. It will conduct less electricity. Its ability to conduct electricity will be low. Now let's compare both of them together, strong electrolytes and weak electrolytes. So first thing, strong electrolytes, they are good conductors of electricity. Then strong electrolytes contain only ions and they allow a bulb to glow brightly. So whenever we have a strong electrolyte, what happens if you're passing electric current through that electrolyte and you connect a bulb in the circuit? This bulb will glow brightly. So strong electrolytes allow a bulb to glow brightly. Then example, hydrochloric acid, sodium hydroxide or sodium chloride. These are some of the examples of strong electrolytes. So a strong acid, a strong base or a normal salt will be a strong electrolyte. And let's see for weak electrolytes. Weak electrolytes are poor conductors of electricity. They contain both ions and molecules. So when this in a solution state, they will have ions also present because some of the molecules will have ionized, and also they will have molecules because there will be some molecules which have not separated, which have not ionized. Now weak electrolytes allow a bulb to glow but dimly. So in weak electrolytes the bulb will glow but it will glow very dimly. Example, carbonic acid, ammonium hydroxide and lead acetate. So some of the examples, carbonic acid, ammonium hydroxide and lead acetate. Now let's see water. Water is considered to be a weak electrolyte. Now why is water considered as a weak electrolyte? Water contains covalent. Water is a covalent compound. It contains hydrogen and a hydroxide ion. So it's a covalent compound. It's bound by a covalent bond. So it does not separate or ionize totally. It is neither acidic nor basic. It's neutral. Water is known to be neutral. But we all know water contains some kind of salt, some kind of minerals. And because of the presence of that salts and minerals, it is considered to be a weak electrolyte. Or else, if you would consider pure water is a non-electrolyte. If you take pure water, it will be a non-electrolyte. Water ionizes to a small extent to give hydrogen ions and hydroxyl ion. This I said is because of the presence of various salts present in the water. Non-electrolyte. So what are non-electrolytes? We've seen strong electrolytes and weak electrolytes. So strong electrolytes will ionize completely. Weak electrolytes, they ionize partially. Non-electrolyte are those substances which will just not ionize. They will not ionize. Let's see the definition. A substance which does not contain ions in its pure state and cannot produce ion in its aqueous solution. So basically a compound which is not ionic, that means a covalent compound. Okay, so in its pure state it does not contain ions and it cannot produce ion in aqueous solution. So such compounds are known, or such substances are known as non-electrolytes. It does not conduct electricity. So the most important character of non-electrolyte is that it does not conduct electricity. It contains only molecules. So non-electrolyte contains only molecules. This is a big point of difference. When it comes to electrolytes, or strong electrolytes, they have only ions present in them. Weak electrolytes have ions and molecules, whereas non-electrolytes have only molecules present in them. Example: sugar, benzene, acetone, urea, chloroform and carbon tetrachloride. So these are the various examples. Please keep them in mind. Now let us see electrodes. So electrodes, they are two metal plates or wires or graphite rods or gas carbon rods immersed in the electrolyte through which the current enters and leaves the electrolytic cells. So basically they are the plates, metal plates or wires that have current carrying capacity. So that's going to carry the current in an electrolytic solution. Cathode. So what is cathode? The electrode connected to the negative terminal of the battery. So one of the electrode is called as cathode. Which is the cathode? The electrode that is connected to the negative terminal of the battery is called as cathode. During electrolysis, cations move towards cathode. So cathode, what we have to remember, it is connected to the negative terminal of the battery. It is connected to the negative terminal of the battery, and during electrolysis, cations, which are positively charged cations, move towards the cathode. Now next one is anode. What is anode? Anode, it is the electrode which is connected to the positive terminal of the battery. So electrode which is connected to the positive terminal of the battery is anode, and during electrolysis, anions move towards anode. So anions that are negatively charged anions move to the positively charged anode. So anions move towards the anode. Anions move towards anode in a electrolysis reaction. So what is electrolysis? Let's see the definition. It is the process of decomposition of chemical compound in its aqueous solutions or molten state, accompanied by a chemical change using direct electric current. So let us just see this process of electrolysis once again. The ionic solution that can conduct electrical current to cause separation or decomposition of compounds. It could be molten ionic compounds or aqueous solution. They both are able to carry current, and that is why they are called as electrolytes. Let's take the example of salt. Sodium chloride is not an electrolyte in a solid state, but when heated to 801 degree, it melts. It forms molten sodium chloride. In molten sodium chloride, sodium ions and chloride ions are formed. Sodium ions are positively charged and chloride ions are negatively charged. The positively charged sodium ions are called as cations, and the negatively charged chloride ions are called as anions. These ions start moving. If you insert two metallic plates, they could be made up of copper, and we prefer to use copper because it has a high melting point. So if metallic plates are inserted in the electrolytic cell and connected to a battery, they are capable of conducting current. So this whole apparatus is called as electrolytic cell. So how does it conduct electric current? A metal plate consists of positively charged nucleus and negatively charged electrons which are moving around it. If it is connected to a battery or power supply, the electrons are attracted to the positive terminal of the cell, that is towards the anode. So the electrons flow towards the anode, positive side of the cell, and this helps to conduct electricity. That is why in an electrolytic cell, we can see that electrolytic cell is capable of conducting electricity. So if in an electrolytic cell 2 electrodes are added, could be metal plates. And if it is connected to a battery, then the flow of electrons starts from the positive side of the battery, from the positive terminal towards the negative terminal. So we see inside the solution that the compound separates into anions and cations. The cations are attracted to the cathode, which is the negative terminal. The sodium ions move towards the cathode, which is the negative, which is connected to the negative terminal of the battery, and the chloride ions, which are negatively charged, are attracted to the positively connected electrode. The flow of current takes place, causing chemical reactions, which could be formation of solids or gases or new solutions. So what is electrolysis? Passage of current through an electrolytic cell causing chemical reaction. So electrodes could be metal plates or graphite rods. They could be wires that are having current carrying capacity. Positive electrode is anode, anions get attracted to it. The negative electrode is cathode, and cations get attracted to cathode, thus causing a chemical reaction to take place, electrical decomposition, which is called as electrolysis. Next, electrolytic cell. As we have already seen, the container in which the electrolysis takes place is also called as an electrolytic cell or a voltameter. So it is a non-conducting vessel containing two electrodes immersed in a solution of electrolytes used to bring about a chemical change. So it is the conducting vessel in which the electrolysis takes place. Let's see the topics that we have done today. So first we've seen what are electrolytes, then strong electrolytes and weak electrolytes. So strong electrolytes are the ones that have higher conduction, that conduct more electricity, that make the bulb to glow more brightly. Then we've seen weak electrolytes, which allow only little passage of current. So the bulb glows dimly, that its solution also contains ions and molecules. Strong electrolytes contain only ions, and we see non-electrolytes that do not contain any ions. It contains only molecules. Non-electrolytes solutions contain only molecules. We see in the electrodes, we have two electrodes. Electrodes are conducting plates. They could be metallic plates like copper, aluminium, nickel, platinum, or they could be non-metallic like graphite or gas carbon. So the two electrodes that we have, cathode, which is connected to the negative terminal of the battery, and anode, which is connected to the positive terminal of the battery. And we saw the whole process of electrolysis. So what is electrolysis? That is the decomposition. It's the decomposition of a substance, the decomposition of a substance due to the passage of electricity.